Hey, good morning, team. Welcome to week three of data analytics and business forecasting. Today, we're going to be walking through a few different areas. First, we're going to do a review of week two assignments. We want to make sure everybody understands how to complete the week two assignments because week three, again, builds on those. So I want to make sure everybody understands that. We're going to go through the different types of inventory systems. If you notice, your week three discussion talks about various different inventory systems. I'm going to walk you through about 8 different types so you can see some additional areas. And then this week, we're really going to be focusing on multiple regression analysis. You saw that back in week two. So in this lecture, we're going to go through 3 different examples that we can go through in order to ensure everybody understands the concepts, how the equations are created, the dependencies between variables. I want to make sure everybody understands. So why don't we get started? So week three deliverables. This is actually a nice light week compared to previous weeks. We do have the discussion thread on supply chain management due Wednesday by close of day, and then your 2 peer responses by Sunday. You also have by next Sunday the um, exercise around optimizing strategy of supply chain management. So we'll go through those. Just remember on the discussion threads, please make a minimum 250 words, 1 APA reference, and then make sure your 2 secondary posts are completed by Sunday. Now, since we're going to be doing this class remotely or on video, I do apologize. I will set additional office hours on Saturday, which would be January 6th, Saturday, January 6th, to be in the afternoon. If you have any questions, I will still have this Thursday's office hours, which will be January 4th. But if you have questions, please text me, email me. I can see if I can arrange some additional time. So, because we're doing this remotely, I have 3 questions we're going to be covering through this lecture. If you please email me the answers, I will record attendance through the questions. So one of the questions is going to be around one of our samples we're walking through. It's, how high can you place a 12-pack of beer before it will not even sell a single case? So we'll walk through that example. We'll show you how to do it, how to create the equation, and then you can determine that answer. Now, the second example we'll be going through is really around cars. I have some data pulled together on different types of cars, cylinders, their weights, and their acceleration 0 to 60. And from that data, you can create a model and be able to estimate how many miles per gallon a car will have. So I want you to, after we go through and build out that equation, tell me what the 3,000-pound car doing 0 to 60 in 10 seconds and has 5 cylinders, what would be the estimated VG? Now, the third example we're going to walk through is grades your students. So it's some data around how long students study, what grade they got on their previous exam, and what their attendance in class was to be able to estimate their final exam score. So these are the 3 questions I want you to be able to answer and respond back. So this class, we're going to be doing a lot of examples, and I will ensure this deck as well as the Excel examples are in our Microsoft Teams chat. So please go to that chat or that Microsoft Teams channel, download the presentation, download the different examples so you can do them through this lesson. Okay, so with that, I cheated. We'll go to inventory systems first. Then we'll go into week two examples. So one of the discussion threads this week is really going through and questioning different types of scenarios and what inventory system would you choose. Now, the book talks about a few. I'm going to show you 8 different models, so you could think about the different models. And you may want to, alter your post or your responses based upon these 8 different types of models. So the book talks about the periodic inventory system. Now, that is one where, you're doing an inventory once a week or once a month or quarterly to see what the inventory is to determine what you need to purchase. So periodic inventory is used all the time. They can take a look at if I only have 12 cars in my car lot and I really should have 20, then I know how much to purchase or restock on a monthly or quarterly basis. That's one way. Now, the other way is called a perpetual inventory system. And that is an inventory system that tracks when every single transaction is made. So let's say I'm selling mobile phones. For example, mobile phones in a T-Mobile store. And every single time I sell a certain type of phone, my system automatically updates so I know to purchase another one to replace it. So that's a real-time inventory updating system. Now, there's also just-in-time inventory systems. So these are traditionally considered to be trigger systems. When my inventory gets down to 5, then I restock. So this one, you take a look at what are your inventory levels, how low can they possibly go before you order new goods to restock. That's the third one. There's also ABC analysis. ABC is a little more complicated. Your inventory is based upon importance. So, inventory A items are the most valuable. I really need to stock those at a certain level. Inventory B, not quite as important, and then inventory C. So let's say I'm running a pharmacy and I know these types of medications are absolutely required. My patients cannot go without these for more than a day. So I know I need to be able to keep that inventory very up to date so I never run out. Inventory B may be lower importance chronic care type of medications, and C might be band-aids. So I know how to be able to order based upon the importance of different items. So far, do the first 4 make sense? If not, send me an email. Uh, for other areas, they're called bulk shipments or economic order quantity. Now, this one, you order restocking inventory at the largest amount you can to keep costs low. So unlike the real time where if I sell a phone, I reorder a new one, the bulk may be, well, after I sell 10 phones, order me 10 because I know I can get a 20% discount or 30% discount. So it lowers my cost. So bulk shipment is really critical when you want to be able to keep your inventory costs as low as possible. Now, safety stock. Um, this is a buffer to be able to handle uncertainty in supply and demand. So what that means is I know I need to be able to have this much inventory in stock, but I really should keep 25% more in case something happens. So let's say, um, let's use an example of uh, cars. Make an easy one. So I have a car lot that has 100 cars on it. I know that we're going to have some upcoming sales. I may want to have an extra 10 or 15% in inventory in case my sales go phenomenally well and I run out of inventory. That's one way. Consignment inventory. Now, this one is where your vendors put inventory at your location, and as I sell, then I pay the vendor for what I sold. So that way I don't have to buy things up front, incurring that cost. It's sitting in my store, and I only have to pay for the inventory when it sells. So that's called consignment inventory model. Now the other one is a vendor managed inventory. Now like Home Depot and Lowe's use a vendor managed inventory, especially for their garden and their plants. So they're not really buying plants. They have their suppliers, the nurseries, come in, they stock, they manage, they clean up, they remove old inventory. They are totally responsible for that inventory you have in your store, and they receive funding when things sell. So that's a great model to take risks off of yourself and put it back onto the vendor. So there's like 8 examples of different inventory vendor management systems. Think about those as you're writing your post and see which one you may change and alter based upon these new models. Okay, excellent. So let's jump into our week 2 assignments. So one of the week 2 assignments was, your travel agency. And we reviewed this last week. I want to make sure everybody really understands. Um, so you're a manager of a travel agency that has travel agencies in 12 different cities, and you believe that the number of bookings is dependent upon the local area's income. So if city one or location one, the average income is $43,299, and I get 1,098 bookings, I think there is a relationship, which means income, if income goes up or down, it impacts what my booking is. So that was the assignment. So we reviewed last week. Again, this is very critical because your plots, your charts, your graph, your analysis will be completely incorrect if you do not clearly identify the independent variable versus the dependent variable. Now, remember, independent variable is what you're trying to study. So, I'm trying to study bookings based upon changes in daily income. So bookings is my Y variable. Income is my independent or X variable. So if you look at the X, Y on a graph, the Y goes up and down vertically, the X goes horizontally. That is what you want the image to look like and to be able to determine the relationship between the two. So when we did this, it should be bookings, your dependent variable on the vertical axis, and your income on the X axis. And that way you can see the relationship. So if I look at the Excel, let's see if I can open the Excel correctly. If you look at bookings is your Y, X is your income. Now, a little trick or a little thing you should be aware of, when you're using the graphing capabilities, such as a scatter chart, when you highlight the fields like this, Excel always expects your first variable in this column to be the X. So if you did a scatter chart of just this, you would have gotten the income on this axis and the bookings on that axis, which gives you a incorrect chart. So, and incorrect calculations. So in order to make this work, all I did was copy bookings to this side. So when I highlight, this is my X, this is my Y, and it creates me a nice graph showing my number of bookings based upon the income of the family in that area. From that, I can do my summary analysis to be able to see what the X, Y equation is. So you can see, remember, go back to your Y equals N, which is your slope, X plus B. So intercept is your intercept, and income is there. So your Y, which is your number of bookings, equals 0.0194 times X, which is your income, plus 371. Now, if you look at this, what this means is the data shows that your bookings increase as your income increases. So if this was a negative number, then the slope would be going down the opposite direction. That the more income you had, the less bookings. So this just shows the shape is going a positive trend, a negative trend, or a neutral or no trend. So this helps define that. Okay? So when we take a look at all the different variables in the summary output, we'll make sure we go through this so you understand what each of these mean. Again, this is a good reference chart for you. So when you look at multiple R, that's called your correlation coefficient. So all it does is measure the strength of the line. So if I go back to my line, if you see all the areas are relatively grouped around the line, so it has a good positive trend or correlation. And that's what it shows here. So we're seeing a multiple R 0.88, which is a pretty strong relationship between income and the number of bookings. Now, R squared is the strength of the relationship of your model. So if you look at this, R squared is 0.77. What that really means is income, your level of income accounts for 77% of the number of bookings. So that's how strong the correlation is. So that also tells you, something else is causing the other 23%. Now, it could be store location, it could be many different things, but this shows that income is very, very closely related to number of bookings in this model. Your standard deviation or your standard error, all that does is 78. All that means is, the distance between your model, your estimate, and your actuals can vary up to 78. That's all it means. So we take a look at the p-values. Now remember we talked about the p-values you want very low, um, 0.05 and under. So when I take a look at income, my p-value is 0.0001. That means that income directly impacts the number of bookings. It's very statistically significant, and there's a very low probability that's due to other or random noise. Now, based upon the coefficients, y equals your intercept plus your income coefficient times income. That's your equation for the line. So with that, you have the equation. You could easily plug in 25,000, 50,000. So let's say you want to open a new store where the average income is only $25,000. You can plug that into this equation and determine that you're going to probably get 856 bookings plus or minus your standard error, which is 78. If you were picking a city that average income is 50,000, you would expect 1,340 bookings per month, plus or minus 78. So that's how you can use this model to be able to determine. Okay. Now, your other assignment. Well, this was a little more difficult. This gets into more of the multiple variable regression analysis. This is where you are looking at seasonal sales over 5 years and taking a look at season 1, season 2, season 3. So if you look at what are you trying to figure out? Well, you're trying to figure out your dependent variable, your Y, which is your sales. Your independent variables is your time index. You have to add this in showing this is time index 1 through 15. And then when you look at season 6, it'd be 16, 17, 18, and your variables. So from this, you can build out your model showing, let me just bring it up real quick. So with this, here's your sales, your Y, and then you're using time index season 1, season 2 to determine what your X value is. From that, you can get your summary output showing your intercept, your time index, your season 1, and your season 2. So from this, you can build out the equation to be able to determine what season 16, season 1 of year 6, time increment 16, 17, 18, what your projected income is. So with that, you build out the model, and you can see that the p-value is over 0.05, and for time period. So if you look at it, it's not that accurate of a model, but it does give you a good directional view as far as what your season 6 sales would be. And again, you plug it right into the equation to be able to determine. So this is how you do it. If you have questions on this, just let me know, and then we can go into further or more detail. Okay. So with that, let's talk about an example. And this example may be very, very, very familiar to you since it's a week 3 assignment. So with this, what you're doing is you're a product manager for a ski wear company, and you want to be able to forecast going forward what your sales are. And you have this hypothesis that your sales are related to two things. One, the income, and two, unemployment rates. So she pulled together, from March of 2007 through December of 2011, so about 5 years worth of data showing what the sales were, what the income was, and what NRUR, which is your unemployment rate, what the unemployment rate is. So she believes that income or unemployment or both impact what the sales are. So you can't really tell from this because you see unemployment's been all up and down, as low as like 6.2 and as high as 11.5. So unemployment's been all over the place. Sales have been anywhere from 72 up to 315,000. So the first thing you have to do is, well, what is my independent variables and what are my dependent variables? So again, ask yourself the question, what am I trying to figure out? And that's your dependent variable. So if you look at this, what are you trying to figure out? Your sales. And you believe your sales depends upon your independent variables, which are income and unemployment. So when you're looking at this, let's run through the example. And I'm going to basically walk you through how to do this, but I want to make sure you take the time and provide a good qualitative analysis on what this information means. When you can follow these steps, they're pretty easy to follow. I want to make sure you understand what each and everything means. So if you look at this, your sales is what you're trying to determine, your why, your income and your unemployment is what you think can change your sales. So with this, go to your data, go to your data analysis. You're doing regression. So if you look at your Y, that's your sales. Okay. And then it's based upon your two dependent variables. And I put labels because if you look at, we have labels in there so I can see very easily. I'm going to say, oh, let's put it on a new sheet for me. And then show me what the data means. I say, okay, well, there you go. A little bit bigger for you. So if you look at this, first thing you look at is, what's your multiple R and R squared? Well, these are pretty close to 1. So I think I have a pretty good model in hand. So I take a look at, okay, so my equation would be, my sales would equal my intercept plus my coefficient, which would be 126.08 times my income plus my unemployment, which is negative 2708.44 times my NRUR. So that's the equation to be able to estimate your sales based upon the income and the unemployment rates. So if you look at the coefficients, income, it's positive, 126. So this has a positive impact. So if my income goes up, my sales will go up. If you look at unemployment, negative 2708 means every percent of unemployment, my sales go down by 2,708. So this tells me right off the bat, I know if I have more income, my sales are going to increase. If I have more unemployment, my sales will decrease. So, makes sense? So let's take a look at the p-values. Remember, we want to always look at a p-value under 0.05. So if you look at income, that's scientific notation. That means 6.71 times 10 to the negative 17. So that means take your decimal point, go 17 zeros behind the decimal point, 671. So that's really, really, really far under zero point zero 0.05. So that means income has a very, very direct relationship to my sales. Now, if I look at my unemployment, 0.41, that's above. That means my sales are really not impacted that much by unemployment rates. The unemployment rate can swing 2, 3, 4% and really will not have a major impact on my sales. So when you take a look at your R squared, you know how I said, well, that's 86%. It means 14% is really changing my sales some other way, some other variable. Well, it's probably not unemployment. It might be store location, it may be average price, other things. But if you look at this, you still have a nice mathematical model to determine what your sales are based upon income and your unemployment rate. So, okay. So, if you look at this, again, um, 0.93, yep, pretty close to 1, pretty direct relationship. If I take a look at the 0.86, my R squared, that means income and unemployment account for about 86% of the sales. So these are good variables. I take a look at the standard error. That means my sales are fluctuating, plus or minus 26,000 from my equation. So when I take a look at my sales equation, intercept plus income times 126.08 minus unemployment times 2708, this answer is going to be plus or minus 26,133. So if you look at it, that means that your income p-value, you see right here, the negative 17, is very statistically significant and a very low probability that the result I'm seeing is due to something random. It means it's pretty accurate. My unemployment, point 41, typo, let me fix that, 0.41. It means there's a 41% chance that the results are random and really does not impact my sales. So hopefully that makes sense to everybody. Hopefully you're starting to understand what these values mean, how to derive the equation, how to start using this tool to estimate going forward. Now, this regression analysis companies use. In fact, my wife was a VP of marketing for many years for a car wash company. And her team, and she had to do continuous multiple regression analysis to determine the locations of car washes, material and inventory use, pricing models, which packages customers prefer the most. It was used continuously to be able to optimize the company's sales, profitability, inventory. So people actually use this, and hopefully you're getting a good understanding of what this is like. Okay, So here's what we're going to do on the three examples. I'm going to kind of walk you through the different exercises. And what I want you to do, after I walk you through what the Excel looks like, what the data is, I want you to take 10, 15 minutes and see if you can come up with the right solution. Take a look at it and then restart this video after the 10, 15 minutes of working through it on your own. And then I can walk you through what the solution is to help reinforce that. Because I really like to have you guys try to do these on your own. And then I can walk through and show you how to do it if you have questions. So let me walk you through the first one. So in this exercise, you're taking a look at beer sales. I think that's pretty appropriate for a college. And it's the number of sales for three different size packages, a 12 pack, an 18 pack, and a 30 pack. So with that, I want you to determine which ones are the dependent and independent variables. I want you to determine an equation of the cases sold by price of each of the different areas. And then I want you to uh, estimate what the sales would be if a 12 pack was $8, or a 18 pack was $15, or a 30 pack was 22. And then the question I want you to submit to me in an email is, how, how can you put the 12-pack price to before you want to be able to sell a single case? So let's pull this up. Okay, so if you look at the data, it kind of shows you by week the price of the 30 pack and number of cases sold, the price of the 18 pack and number of cases sold, and the price of the 12 pack and number of cases sold. So start thinking about what's your independent, your dependent, what the equation is for each of these three, and then be able to then determine and estimate the cost for each. So with that, let me pause the video. I want you guys to go on and be able to try to determine this, and then restart the video and I'll walk you through the example. Okay, are you guys ready to go through the solution? Now, if you look at these are actually some simple, direct, single linear regressions. So if we take a look at it, here's the price of your 12 packs. Here's how many one you sold. Okay, so what are you trying to figure? How many I will sell based upon the price. So if you look at this, your price is your X, your independent, and you're trying to figure out the number of cases you will sell based upon the price. So with this, straightforward, simple, you select and you say insert, give me a graph, here's a scatter plot. Now, if you look at the scatter plot, they kind of grouped in here. What I would do is I would take a look at my axis and just make it a little bit cleaner so I can see it. So change my, let's make it $12 there. So this shows, based upon the price of the case of the 30 pack, how many I will sell. So if you look at this, let's add in a trend line. Let's make sure we show the equation. Equations are up here. So let's make this a little bit larger so everybody can see. So if we look at this, the equation is showing a downward trend. So the higher I set the price, the lower the number of cases I will sell. So if we look at this, it's a negative 124.44 times the price plus my y-intercept. So I know that for every dollar I increase the price of the 12-pack, my sales are going to go down by 124 cases. So based on this equation, if we look at the questions, if my 30-pack was $22, how many would I expect to sell? So I go back. So if we look at the equation, which is your sales, that equals negative 124.44 times the price, which is $22, plus 2774.5. So I would expect to sell, if I went all the way up to $22 for a case, I'd probably only sell 36 or so cases. Now, if my price was $10 a 30-pack, I'd probably sell a lot more, 1,500 cases. Actually, $10 for a 12-pack, I'd probably sell every single one and then some. But this kind of gives you a direct equation. So if we take a look at this, you do the same thing for your 18 packs. So if I take a look at my 18 packs, insert scatter chart, I can change my y-axis. Let's see. There we go. So with this, it looks like the same kind of equation. Let's add in a trend line. So we want to add in a trend line. Make sure I display the equation. So for 18 packs, every dollar I increase, my sales goes down by 93. So use the same equation to be able to determine if my price for a 18-pack was $15, how much should I sell? $15 times negative 93 plus 18 will give you the equation. So this is a very simple way of being able to predict based upon the price of my product what my sales would be. That's just as simple. Okay, so with that, fill this, close this. Okay, so you can do the same thing for a 12-pack. If I drop my price down to $8, how many would I expect to sell? So what I want you to do is take that example, take a look at the 12-pack, and tell me how high of a price I would set it before I couldn't even sell a single case. And I want you to send that to me. Okay? Perfect. And hopefully that was pretty straightforward. Again, it's simply just determining a single variable forecasting equation. So let's dive into something a little more complicated. Let's go into a multiple variable regression. So in the Excel, I show the different car models, what their MPG was, how many cylinders they have, what is the weight of the vehicle, and what is their 0 to 60. So I'm hypothesizing that my miles per gallon is dependent upon how many cylinders I have. 4 cylinder, 6 cylinder, 8 cylinder. I think my EPG is dependent upon the weight of the car, if it weighs 1,000 pounds or 10,000 pounds, and that the 0 to 60, how fast it can accelerate, impacts my MPGs. So that's your goal. Take a look at this sheet, go out and do a regression analysis using the analytic pack to determine an equation that shows what the MPG is based upon cylinders, weight, and 0 to 60 speed. Then I want you to take a look and see which one has the most significant impact in determining the MPG. And tell me if you think this is a good model or not. Okay, so I'm going to pause it. Go take 10 minutes, take a look at this Excel and see if you can come up, and then come back in and we'll walk through how to do this. Okay? Okay, so how would you like to, were you able to figure it out? Okay, so when you walk through this data I pulled, it shows, I believe, about 300 or so different cars. Let me just see how many. 300, 393 different cars showing, showing what their miles per gallon, how many cylinders they had, the weight of the car, and what their 0 to 60 was. So from this, I have a Chevrolet Malibu with a V8 weighing 3,500 pounds, being able to do 0 to 60 in 12 seconds, got an average of 18 miles per hour. And with this, we're going to build out the equation. So, did you figure out what the independent versus dependent variables are? Okay. What are you trying to figure out? That's your y, miles per gallon. So this is what you want to figure out. And you believe miles per gallon is dependent on these three variables, independent variables: cylinders, weight, and seconds. So we go up into our data analytic pack. We want to do a regression analysis. And your y is your miles per gallon. Okay. And you believe miles per gallon is dependent upon cylinders, weight, 0 to 60. I put labels on top, so they're there. And just put the analysis over into a new spreadsheet. That's fine. And say, okay. Okay. So here is my analysis. Let me just put it out a little more. If you can see it. So from this, you have the coefficients. So now you know MPG is equal to negative 0.489 times the number of cylinders plus negative 6.476 times the weight plus 0.2138 times my acceleration. So from that, I've just built an equation that tells me if I have X number of cylinders, X amount of weight, and a certain amount of acceleration, what my miles per gallon is. So let's go back up, take a look at our multiple R and our R squared. Okay, R squared is a little bit lower, zero point 0.7. That tells me that cylinder's weight and acceleration account for about 70% of the MPG value. So it's an okay model. It could be better. It could be something else that determines miles per gallon better. Now, also, I know I have a standard error of 4.2, 4.3. So if I put in these numbers, my actual miles per gallon could vary 4 miles per gallon higher or lower. So it's a pretty big range, but gives you a little bit of a good idea. Now, if I go take a look at my key values, cylinders, well, zero point 0.1. No, that's not under 0.05. So the number of cylinders really didn't impact my MPG that much. If I take a look at the weight, oh, absolutely negative 25. So with that, I know the more car weighs, the lower the MPGs are. And if I look at my acceleration, 0.019. Well, that's under 0.05. So there's definitely a correlation between how fast my car goes, accelerates, and my miles per gallon. And if you think about it, cars that can accelerate very rapidly typically don't get the greatest gas mileage. So with that, I can build out a very nice equation to be able to tell me how to determine miles per gallon. So, delete that and delete that. So if we look at this, you you're now able to determine, you know, how it's related. And if you look at, let's look at slide 15, back up to the top. So if you had a car that weighed 3,000 pounds, did 0 to 60 in 10 seconds, and it had only 5 cylinders, tell me what you think the miles per gallon would be. Okay, let's see. Okay, now, one last one. And we'll walk through this example, and we'll see how you guys do. So with this example compares students, how long they study, what they received on their last exam, what was their attendance? Did they attend 100% of the time, or 88% of the time, or 90% of the time? And then a final exam score. So you got all this information here. You want to figure out an equation to determine what the final exam score would be based upon these three independent variables. So take 10 minutes. Make sure you can determine, even though I just gave it to you, dependent versus independent. Determine an equation that relates final exam scores based on hours studied, previous exam score, and attendance. What you think the most significant factor is, and then you need to answer a question based on your equation. If a student studied for 13 hours, got an 80 on their last exam, but attends 100% of the time, what would you think their final score would be? And tell me what the error would be, the standard error. So that's what I want you to do. So take about 10 minutes. I will include this data in the Excel, and that will be in the Teams. Try to run the regression analysis, determine the equation, tell me how good of a model it is. Okay? Okay. So here's the data right there in Excel. Hours, previous exam, the attendance, and final exam score. So did you figure out what the y variable is when we're trying to determine the dependent variable? We're trying to figure out what the final score is based upon these three independents. So let's go do our data analysis. We want to do regression analysis, your Y range, final exam, your X or your independent is hours studied, previous exam, and attendance. I included the labels, and let's just put the pounds initial. That's fine. Okay, so say okay, and there we go. This is a little bit bigger. A little bit too big. Okay, so with that, I take a look at the multiple R and the R squared, 0.90. That tells you pretty close to 1. Over 90% of the things that could impact the final exam score is captured by those three variables. Hours studied, the previous exam, and the attendance. So that looks pretty good. The standard error, about 0.4. So I know by equation, the final exam score, you're going to probably be plus or minus 4%. So that's pretty good. I can build out my equation from here and my coefficients. And if I look at my p-values, they all pretty bad. So let's take a look at what the equation is. So my final score is equal to my intercept, which is 39.4 plus hours studied, right, times 0.89 plus negative 0.035 times my previous exam plus 0.3445 times my percent attendance. So that's the foundation for your equation. So let's take a look. So final score is equal to y-intercept plus hours studied, which would be hours studied here, plus we'll put previous exam score here, plus percent attendance, there. Yeah. So this was hours studied. So right now, if I study 0, I got a 0 on my last exam. and I never attend class, I will probably get a 39 on my final. Now, let's say I actually studied a little bit, within 5 hours of study time. No, so for every hour of study time, my grade should go up almost 2%. Now, let's say on my previous score, no, I got an 85. I did really well. Um, Even though I got 85, I studied 5 hours, I probably get less. And if I attend 100% of the time, I'll probably get 80. So from here, if I study 10 hours and I got a 90, so my previous score really had a negative impact on my final score. So if you look at it, these are not very statistically relevant. Obviously, they're not that accurate. So if I were to study, let's say, 15 hours, I got a 90 on my previous, and I attended every single class, I'd probably get 99 plus or minus 4. That's it. So now, obviously, for this example, um, in the real world, you need a lot bigger data set. Building a model only on 5 or 6 or 8 variables is not the greatest. That's one of the reasons if you look at the car scenario, there's this one, car scenario, I had almost 400 different variables to get a much more accurate representation. But this is a good way of seeing that. So what I want you to do is um, build the model, take a look at 13 hours of study time, 80 on the previous, and always attended. What do you think the final score will be? So with that, those are the 4 different um, samples or examples for week 3. All of them are really dealing around multiple regression analysis and how to determine it. Remember, when you're this week, take a look at your discussing different supply chain management strategies. Again, that goes back into different types of inventory systems. And then take a look at the assignment, how to optimize efficient supply chain management. And that goes into your multiple regression analysis. So that's two, it's this one. So that's this one's determining sales around um, inventory and accuracy. Okay, so with that, that was week 3. Um, Again, all of this presentation, the Excel templates to be able to do each of these will be in the Microsoft Teams chat. Please review them. If you have questions, please let me know. Again, I'll have office hours on this Thursday, which is January 4th, and then I'll have additional office hours on Saturday afternoon once I arrive back in Virginia. So with that, you guys have a wonderful week. I will get this posted today, which is December 31st. So you guys can watch this early, figure out the equations. You have plenty of time to do it. And let me know if you have any questions. Thank you guys so much.